All right, we are working on 7-1, completing the square. I'm going to be up front. Not my favorite topic, but here we go. So the first one, number 7, is we're taking this equation and we are going to solve it. Instead of multiplying this out and factoring and all this, we're going to solve using radicals. So I'm going to go ahead and do that. So multiply by 4 to get rid of that. So that's going to give us x plus 3 equals 32. Now, to get rid of the squared, I'm going to use square root. So that is going to be x plus 3 is equal to plus or minus the square root of 32. Let's see, 32 is going to be 16 times 2. So that's 4 root 2. And to get the x all by itself now, we are going to subtract. So minus 3 on both sides. So we end up with x is equal to negative 3 plus or minus 4 root 2. If we ended up with a negative over here, we'd be working with some imaginary solutions. Process would be pretty similar, except we just have a little I in our problem, right? This represents both solutions to that quadratic equation. All right. Number 10, we have this equation in this form right here, and we are going to do the process of completing the square in order to set it up like this and then set it up like the previous problem and then solve it. Okay. So I like it to be in standard form to begin with, so I don't really love that. Move things around. All right, so standard form. We could try to factor this. Doesn't look like it is factorable. We could use the quadratic formula, which is based on completing the square, but that's not what we're doing right here. We're going to do completing the square to solve it. Okay, so here's what I do for completing the square. I'm going to move the constant term over, give myself a bit of a space right here, equals 5. Right, I had to add 5 to both sides, so when I move it over, it's positive. All right. Now, I want to turn this into a perfect square trinomial. So what I need to add here is half of the middle term, half of the b term squared. So it's going to be negative 3 over 2 squared. That's just going to be generally the process we do with this, because that's going to turn it into a perfect square trinomial. So doing that, we're going to end up getting 9 over 4. So that is what I'm adding to my equation, so plus 9 over 4. But I kind of created that out of nowhere, so in order to keep my equation balanced, got to do it on both sides. Okay. Now this side, 5 is really 20 over 4. So the right side is going to end up being 29 over 4. And this side ends up factoring as a perfect square trinomial. It ends up factoring with this as my constant part for this. So it's going to be t minus 3 over 2 squared. That's the clever thing that we did here. We turned this into a perfect square trinomial, even though it had kind of this messy fraction in it, where the constant part here in this binomial was half that middle term. All right, and from here we solve it. We take the square root of both sides. We get t minus 3 over 2 is equal to the square root of 29 over 4, which is really the square root of 29 over 2. Remember, plus or minus, because we're solving, we always have to account for both the positive and negative root. And then I am going to add 3 over 2 to both sides, get rid of that, giving us a final answer of 3 over 2 plus or minus the square root of 29 over 2. Yay. All right. Next couple. So this one here, what is different from the last one is we have a leading coefficient. I'm going to start similar to the last time. I'm going to go ahead and move that over to the other side. So I'm going to get 2k squared minus 8k plus something equals -5. Now, there's one extra step here. I'm actually going to factor away this leading coefficient of 2. So it's going to be 2 parentheses k squared minus 4k plus something equals -5. All right, now we need to turn this into a perfect square trinomial. So I take half the middle term and square it. So it's -4 over 2 squared. That's -2 squared. That's going to be 4. That's what I'm adding right here. I'm just adding 4. Got to do it on both sides, but a little bit of a trick. I am actually not only adding 4. Because of this coefficient out here, which would be distributed to it, I'm actually adding 8. So I got to add 8 to this side. That's a little bit of a tricky thing that can happen when you have to factor away this coefficient. All right, now this is a perfect square trinomial. Factors as k minus 2 squared. Still have that coefficient of 2 right there. And my right side is now -5 plus 8 is 3. Okay. Pretty close. Now we want to solve it. So we can solve this at this stage. So we're going to divide both sides by 2. Get rid of that. So I get k minus 2 squared equals 3 over 2. Now I need to start using my square root. So I take the square root of both sides. I get k minus 2 equals plus or minus square root of 3 over 2. That will need to be rationalized here in just a second. So square root of 3 over 2. I need to multiply by the square root of 2 on the top and the bottom to get rid of that. So that becomes square root of 6 over 2. Okay. Adding 2. I'm going to get a final answer here of k is equal to 2 plus or minus the square root of 6 over 2. Square root of 6 over 2 comes from doing the rationalizing there. All right, final one. Aren't these so much fun? We have this one right here. So as you can see, leading coefficient of 3 and then a 7v for this. That's going to be beautiful when we have to factor it out of 3 and everything. But starting out, I'm going to move that 4 over. Okay, now I'm going to factor out the 3. Seven over 3v something. Okay, and now I need to turn this into a perfect square trinomial. So I have to do the middle term divided by 2 and then squared. So 7 over 3 over 2 squared. 7 over 3 over 2 is really 7 over 6 squared. That's going to be 49 over 36. And that's what I'm putting in right here. But remember, I'm just adding that to this side, so I need to add it to the other side, but don't just add 49 over 36, because really it's 3 times that. The 3 would cancel with the 36. They're both divisible by 3, so that would really be 49 over 12. Right, because if I multiply this by 3, the 3 cancels, becomes 1, and 36 becomes 12. So that's where we end up with that. So wonderful. I'm going to go ahead and rewrite what I have here. Oh, almost. Remember this, the whole point of this was this trinomial factors is a perfect square trinomial. So we end up with v plus 7 over 6 squared. This thing is always half of the middle term, half of that coefficient there. So that's why you're doing it. Okay, and these go together. -4, I can convert that to twelfths. Multiplying by 12, 4 times 12 is 48, so this is -48 over 12. So -48 plus 49, actually that's pretty nice. That's 1 over 12. Seems like that's one of the first things that's been pretty nice here, but can't be too picky. Okay, let's go ahead and get rid of that 3, so divide by 3. So I end up with b plus 7 over 6. 1/12 divided by 3 becomes 1/36. Yeah, 1/36. And we will square root this, because we have to. So now we're solving. That becomes v plus 7/6. And actually, this is really nice. Those are both perfect squares, 1 and 36. This becomes plus or minus 1 over 6. And now to get the v all by itself, I'll simply subtract 7/6 from both sides, which is going to give me v equals -7/6 plus or minus 1/6. And since those don't involve any radicals or anything, I can actually figure out specifically what the two solutions are. So -7/6 plus 1/6, that's actually just -1, -6/6. And then -7/6 plus, minus 1/6 would be -8/6, which reduces to -4/3. So these are actually our two solutions. As messy as that was along the way, that actually wasn't so bad, and kind of leads me to believe that that was actually factorable using our regular normal factoring, and would have been easier than this. But we did it by completing the square, and there you go.